Okay, problem number 2. I have a thiol and I have an alkoxide. I want to know what side will the equilibrium lie. And again, my factors are here. When I think about which is the acid and which is the base, again, I think negative charge has got to be my base, right? Because it is aggressive. So when I start drawing this out, I'm going to draw first. I'm going to redraw my structure. I'm going to draw the resulting acid-base chemistry. And here is my situation. I've identified my acid, I've identified my base. Acid, base, and I have my conjugate base and my conjugate acid. So again, the question is, which base is more stable? Electronegativity, yes, that plays a role. Size, that plays an even more important role. Because remember in lecture, we say if you are debating between two elements and their stability, electronegativity is going to be based on if the elements are in the same row, and size is going to be an argument used if they're in the same column. Again, there is no resonance, the hybridizations are the same, and inductive effects are insignificant compared to what we have already based off these two arguments. So what we do know is that the electronegativity of O is greater than the electronegativity of sulfur, but the size of sulfur is way bigger than the size of oxygen. And because the size of sulfur is way larger, if we think about it, it's sulfur as an atom, here's oxygen as an atom, that negative charge can get dispersed. It's almost like if you spray aerosol on planet Earth, you'll never be able to find where you sprayed. And if somebody on the opposite side of the planet, they're not going to be able to smell that aerosol or smell that Febreze because it's such a large planet, it's such a large atom, that charge or that Febreze you sprayed gets completely lost and diminished throughout the entirety of the atom. Oxygen's way smaller. So oxygen's like if I stand in the same room as you and I spray Febreze on the other side, you're going to probably be able to smell it because the room's not that big compared to the entire globe that is sulfur. And this is a dramatic representation. Their sizes aren't actually that fundamentally different between planetary and a room in a house. But the idea exacerbates the concept I'm trying to, or reinforces the concept I'm trying to explain, is that the size of sulfur outweighs the electronegativity characteristics of oxygen. So this charge is stable on sulfur more than it is on oxygen because it's so much larger and it can bleed it out throughout its entire atomic radius. So when I think about stability, going off that notion, sulfur is more stable. So sulfur can handle this charge because it's larger. So size is a factor. And when we're thinking about pKa's as a justification piece, we know that alcohols come in around 15, and we know thiols come in around 10 pKa. And those are the important fundamental pKa values we should have memorized. So when we're thinking about these, we can validate that it's going to go to the side of the higher pKa. And that's because not of electronegativity, where you see oxygen's actually more electronegative, but it's actually due to size. And that's because oxygen and sulfur are in the same periodic column. And the trend of size in the periodic table, atomic radius increases as you go to the left and down. And sulfur is farther down. So that trend of size dictates the equilibrium direction.